Welcome everyone. Thank you for joining us in this Open Security Summit training session. So we are joined by Vinh, Tram, Mann, Elvin, and we will have a session on JPG and PDF ISG on how to automate inspection and sanitation guidance testing. So let me start with this welcome deck for you. So we expect you to participate in this session, like asking questions, clarifications, and we want you to care deeply on this. Also, we expect everybody to have mutual respect with each other in that you can challenge directly, be solution focused then, and also the summit has openness wherein sessions will be video recorded, sometimes live stream as well, and will later be shared on social media in YouTube, Twitter, and LinkedIn account. And so if you don't want to be identified, let's take personal precautions such as not activating your video and using NA as your name during the session. And we want to inform you that everything created in this session is released under a CC or open source license. And we are all here to collaborate on topics we have chosen as a community. No one should be discriminated or harassed based on your race, gender, age, religion, appearance, or being an experience, or anything else. And so we are all expected to preserve a certain level of professionalism and respect. And if you feel any kind of abusive behavior against yourself or anyone else during the summit, please report to one of the organizers as soon as you can, or you can report it to me or anyone from the summit organization so that it can be handled and prevented from future occurrence. For a hashtag for today, please use hashtag OSS 2020. And if you're not in our Slack channel yet, I'm going to send the invite after this welcome deck and just check on the chat. All right? Okay, so let's welcome our organizers for today's session, Vinh, Tram, Mann, and Elvin.
Good afternoon, everybody. I think this is, I don't know how many sessions we had. We had a number of sessions this week covering the different ISG aspects of it, and it's probably worth a kind of a quick summary of there we are. And apologies because I couldn't make the session yesterday, but I thought it was, when I listened to it on the recording, about trying to cover some of the technical aspects, at least for the PNG, for the CRI, to actually create some of the programming, to create some tests out of it. I thought that was really quite interesting, and I suppose just as kind of a start off, I just think, if has anybody got any sort of like follow-up things that they've done since the meeting yesterday to kind of progress any of those initial thoughts that were put out in the PNG call yesterday?
Oh, I do. This is Wallaby Curtis. I was looking at some of it and thinking about how we could simplify the process of what we're trying to even figure out. The first thing I realized was that, well, it's a complex problem, right? It's completely divided up into so many sections, and the more that we can move the things that we're trying to do towards something that's actually more of a commodity, the easier it's going to be for us to do that. I was looking at Yara for being able to search for information and find like the different patterns in the files. It looks like that would be a really good option for that. And where we end up having the breakdown in our ability to take the language of the ISGs and put it into something that can be used by the machines, I think the easiest way to look at or to approach the process is to think of it kind of in terms of assembly language. You know, you have your basic move, push, pop. These are the things that we're having to actually do with the chunks. If we think of it in those terms and break everything down into that, you know, it's going to be a lot easier. And sometimes we'll have to use regex, but through what the document, I'll drop it in there, but there's a document from Yale that shows how to be able to use or make regex into NFAs and DFAs to be able to actually use it in assembly. So basically, there's a very complex thing that could be broken down into something more simple. The reason I think that it's important to look at those things is because just because of the thought diagram, you're not going to want to code an assembly for, you know, for the entire process. You're not going to want to be doing that, but you're going to want to know how that works and want to break it down into something simple enough where you understand it in those kinds of terms from, you know, yeah, just to deal with that complexity of language. So I'll drop those links in there and see what others have to say about any of it.
I mean, I think that was kind of quite a big part of the, or what's come out of those discussions, isn't it? Is that actually the way that some of those ISG requirements are actually worded, they're kind of quite complex in one hit to actually kind of validate. And I totally agree that you need to break it down into some form of some way, kind of know what you know, just to make it manageable.
Yeah, and that's kind of what I was saying is, if you think about it, I mean, you know, with assembly language, you're not doing much at a time. I mean, you're not doing much. But you think about it in that way, how can I break it down from the language that it's using here to something that is actually that simple? And then even having a diagram of something like the NFA is helpful for understanding how to break something like that down and code it. I mean, it shows what, you know, it shows what's iterative, what you're going to have to use in what different capacity. And even if you're not actually using it directly as the code, you have a nice thought model right there that you can use.
Yeah, I mean that's it's kind of interesting. And when you post things, I like kind of look at this, because I must admit, because I was kind of looking at, you were looking at it from a programming language, and I kind of look at it from a QA perspective, because I'm a tester, of saying actually what would I actually do to do this, and and I think the end result would be kind of fairly similar. It would be like, how do I turn what is a set of fundamentally a set of language requirements into something that you know, is a set of test conditions that I can then generate some tests from, you know, and try to have something that gives me a high level of completeness of when I've actually validated that particular requirement. I'll be really quite interested to kind of, when you see got that stuff, post it through to see if that would give a good representation as I'd understand it as a tester.
So if you look at the last one, oh no, hold on, sorry, I sent them all to Alana.
Can one of you guys share the screen so we can see it?
Yes, you can share screen. I'm really sorry I haven't included Wallaby because I didn't know he's an organizer for this. Apology for that. You can try sharing your screen.
Oh, I actually can't share my screen, but I did send it. The last one there, I think it would be the most useful for you to begin with, just to get an idea of what I'm talking about. Of course, Yara, Greg, you've taken a look at that, and we can talk about that in a moment, but I just wanted to point out how this works. So it's the last one in the chat there.
I'm just having a few issues. I'm just trying to pick the, having a few issues getting to the chat.
I'm going to make you a host.
You don't need to make him a host. I think you can present without being a host.
Just make him a host.
Are those all in one string? Hold on. Let me check.
I'm just wondering what you're sort of suggesting here. Just keeps giving me the impression that you're assuming that the files that we're dealing with that we don't have the structure for. Well, clearly, we already have all the structural information for them, so we know how to break them into the components and identify the specific fields that the ISGs refer to.
That's 3 different links there. No. What I'm thinking of is, and that's kind of what I wanted to show you actually, but this is 3 different links you're looking at right here. You got 3 links there. I just wanted to show you real quick kind of a thought model for the process. And I think the NFAs and that transition gives a good thought model, because if you can break something down simply for how to take a certain form of language and think of it in terms of something different, in terms of a different format, it makes it easier to take the part, or to look at the parts separately, I guess is what I mean. Yeah, there. So if you go down, it's going to be what, 16.1, 2, and then it's going to be, so actually let's go down a little bit further to where you see little drawings and bubbles. You got the regular expressions right there you're passing through. Right here. So you see this? I'm thinking of that as kind of a type of model, in a sense, for the process of taking the language of the ISGs and making it more simple. Does that make sense?
I see. I mean, you're trying to automate the job of extracting meaning from
no, I'm trying to give us a context for how to be able to think about a process. This is down at, okay. Technically, this is at a specific level, right? But what I'm saying is, if you get rid of the information that's here to some extent and look at it as a way of thinking about it, when you have something that's more complex, you can iterate over certain things a number of times with okay. I'm trying to think of it more as a thought model rather than the actual thing that it is. And I get that this would be down in something lower than what you'd be working with most of the time. I'm just saying, if you aim for something simpler with the way you think, then it breaks apart the process and makes it easier. That's basically, long story short, what I'm getting at. This is simple enough in that you have the different sections, and if you go down just a little bit more, you have it broken down. Yeah, so you see more of these. Yeah, here we go. You have it broken down, so they pass through different routes, just showing you the example of what this looks like. This is basically what we have to do with the language, what we have to do with pulling apart the actual language used in there. Does that make sense?
Yeah, so for example, now, this is quite interesting because you almost think about control flows and how you actually describe a sequence of events, right? So we take the object and we take a file, we convert it into an object model, right? We create a tree out of the object. So what you have here is the rules that you can apply to it, right?
Yeah, and so if you take it and you look at it, this is getting down to a simplicity that's going to be too simple for what you really want to do if you keep going with it, right? because then you get down into the assembly, then you get down into the binary. But if you aim for the assembly, if you aim for something like that, with your thought process, then you know, okay, so I'm moving this chunk from here to here. I'm and I'm doing this part of it iteratively until I get to the end of, and this kind of idea is a way to think about it, to model that in your mind, and not just as it is in actual fact on a lower level, but it brings the mind into a place that it's more simple.
Yeah, I'm mindful that there seems to be different things being considered and talked about here. I think there's a difference between looking at deconstructing the specifications into something versus what our actual process is. And I'm still not quite clear what's actually trying to be achieved with that. I mean, I've taken it from the sort of the high level, looking at the specifications and compared them with the types of test sets and mechanisms that we already have, and they're very clearly a generic or more they're either a subset of what we've already got, or they are broader descriptions of a range of tests that we already achieve. And it doesn't seem very easy necessarily to try, and in fact it seems an extremely complex thing to try and automate the job of trying to set their specifications and turn them into tests, whereas actually a lot of them would potentially simply map onto tests that we already have, and we could potentially just mark up that information within our existing tests to extract out and highlight which tests conform to things that are actually specified in those ISGs.
Right. No. I understand. I understand that, and that's the part, like I said, that I'm not really addressing so much. Here we have kind of a flow of where we can take one thing and break it down into something simpler, right? Some aspects of it are going to be iterative, but I'm looking at not how to automate the whole process from that side, but how to be able to think about the process that we're working with in a way that's simpler. So, okay, if the chunk is not, if there's a chunk here before this first one that's supposed to be there, then we need to move that somewhere else. Moving, doing everything though iteratively, and just thinking about those basic, all right, we have to move it, we have to remove it, we have to just take it and make it at that basic level. And then not letting the language of the thing actually get in our way, but understanding that some processes can be broken down into something simpler. And if you have to express it with something like a chart like this, that shows you the paths that it would have to take, this is an easy way of expressing that sort of thing, even if you're not using it as an actual NFA. The concept behind how this works, the process of it, makes it simpler to think about.
You want to get an alert?
Yeah, I sort of see we go. I still, but are you talking about what we do in our system to deal with a? I'm just not clear where.
I think we should look at it.
Refer to.
I think that you got, and I must admit, Steve, I'm struggling a little bit myself. But I think we should kind of look at this outside of kind of what we. I think we should look at this as kind of as a way to actually do this outside of it. I mean, we tend to get very glass and focused on what our technology does. I think we probably need to steer that and just kind of think, it's the concept of representing what's going on. Does it allow you to kind of come up with something that allows us to implement something very easily?
Right, exactly. I'm not talking about directly what is in the code. I'm talking about kind of a process of being able to break down what needs to be done in such a way that it's simpler, but we're not going to be coding, nothing's going to be coded at the assembly language from, the vast perspective, from the perspective of all the code you're going to have to be doing. You're going to have very little that's actually coded at the assembly language. So this would be relatively useless from that angle. And in fact, I would suggest something like Yara from that perspective. But my suggestion is when the things get complicated in those areas that you struggle with to know how do we deal with this way and this way, break it down into something much simpler that actually, if you have to turn it into something like this in your head, then the actual code becomes more clear. What you're going to have to actually do becomes more clear.
So actually, here's the question, right? So I'm looking at this and I'm thinking this is basically you describing rules, right? You're describing a rules engine that you go here, you do this, you go there, you do that, right? That's
exactly.
Kind of, how do we visualize our current rules?
You mean in Glasswell?
Yeah.
I'm not sure if
mixture of DVL code, which I can show you, which is a set of rules connected to particular items to particular structures, or as sort of handwritten code that iterates through our tree looking for particular cross-references.
Yeah, but do you have a visual representation of those rules?
I got something I can, I can show you examples of them.
I'm not sure if Wallaby's trying to get at what I've just posted in the chat, but there's a link to a GIF specification website, which I looked at once, which nicely shows the flow of how a GIF is broken down. And it's at kind of a diagrammatic level at what I think Wallaby's trying to show, I think.
Can somebody share that document so take a view? So I'm not.
I've just posted on chat Zoom group.
Can somebody share that on the screen?
Yeah. Give me a second.
Be counted. So
can you see the screen?
Yep.
Mm-hmm.
So is this what you're trying to get at? So this is the specification for a GIF format.
My understanding was that what you're trying to say is basically you have a certain number of rules that are complex in themselves, as in they're not very easy to come up with a single way to validate. And that's a process to start visualizing that and taking that apart so you can kind of validate them as separate, tinier components, which means that when you implement that programmatically, you've now got a sequence of little steps when in conjunction, they actually cover that overall sort of validation rule that they've added in the ISG. I think that's what I got from it. Is that correct?
Yeah, because the more visual
Yes.
we make this, right, the more component, like the more you bring this to a high level language, to almost a meta language, right? The easiest to write rules, in fact, the easiest to write tests for, right?
Yeah. So
that's basically what I was saying. What I'm not sure who.
Alvin.
Yeah, that's basically what I was saying. We want to have a way that we can think of it and break it down to the simplest language that's actually going to be useful. And yeah, we're not going to necessarily use it in assembly, but we're going to want to think about that move, the push, the pop. We're going to want to think about, what we're at.
An approach to dissect the problem effectively. So
exactly.
a thought process.
Yeah. Exactly. That's going to.
Sorry, go ahead.
But for the whole process, it seems a little granular initially, but you're only doing that at the parts that you have to be granular, the parts that aren't obvious there. Some parts are obvious, some parts aren't.
Mm-hmm. I understand. Yeah.
That's what I was kind of. It's a shame, we've been kind of think about this more. We can kind of work through an example because some of those requirements are actually really quite complex, and it's having, and like I see the value of one of these types of models, whether it's something similar where you can kind of break it down into some representation of what those little parts of it would actually be would be immensely helpful, because I think it's much easier to construct a series of a correct series of tests from that.
We need some mute somebody. Sorry, who has the kids?
I would recommend everyone just mute and let the person currently speaking speak, and unmute when you're ready to talk.
Yeah. Yeah, cool. All right, go on. Who was speaking?
Greg, I believe.
No, I think I kind of got to that. It was that having some model to break down and show those requirements in a simple form, or what does that actually mean? It's definitely needed. I mean, I just think about some of them where it is actually it's because I've been thinking about this quite a little bit about where, especially we have some of the negative tests or the negative requirements, where it's get rid of anything that's not in a white list. And I think it's something where you could actually break down the steps of the processes of what you kind of going to go through to kind of help you get the clarity of how much information you actually need to kind of prove that. It's kind of quite a difficult thing to actually kind of go through. But if you can go, and then you kind of find out, okay, it would be one of those things where you get to and say, actually, I know that there's a huge range of things that can't, that could fall into this set of things that are invalid. I can't test them all, but I can create a concept or visualization of what some of those things would actually be.
And then if you actually read what it's saying in that section and take it and think about it in terms of a thought model, it's pretty wild. It becomes a lot simpler to do a lot of things, but only in those instances where you actually need it. If you don't need it, it's going to take too much time. But using something like Yara would, I think here we have someone back. If you don't need it, it's going to take far too much time to be able to go through that kind of thing. But if it's necessary, that's a very useful thing. But Yara will be something that will take and look through things, in a much faster way. It's much easier to implement, and you're not even going to have to do as much actual development because of what's already put together there, if that makes sense.
But I think Yara, when I saw that, Yara looked like it was good for regex, for when you don't have an object model of the code, right? Of the file.
It'll actually search through and pattern match for pretty much any pattern. They actually have their own form of regex. So in essence, I mean, it's all the tools. Let's see, I can pull that up, but it's all the tools. Oh, right there. I'll grab that real quick and post it back in. But it's all the expressions that would be needed in the ISGs, and it's right there on. I mean, there might be a few others that we would want to develop for ourselves, but that's where we would use that kind of thought model. But I just reposted it in the chat, and it's linked to the section. You just go down like a tiny bit, and it'll be right there. You'll see a chart.
Somebody's saying this.
Someone could share that. See that? Match 0 or more. If you go back up a little bit, you got match 0 or more. Where is it?
Yeah, but this is, like I said, but this is looking, right, not on an object model of the file. This is looking at the raw binary of the file, right?
Well, I mean, if you're looking for chunks within the machine language, this is something that could be used as well.
Yeah,
No,
but
I think that's, sorry, I think that's the point. We already have the structure, so we don't need to sort of do regular expressions looking for items. We can.
I see. So maybe that's the part that
And look, the process for a lot of these things is that you do want to build an object model, right? Because it's a lot more efficient, right? So the better the object model, the better it is, right? So, and I think, what's interesting is that you don't need to create a full-blown object model for some of these things, right? And then when I look at some of the ISGs, I think we might have lighter versions of bits, so you can get that bit extracted from the binary, but you always want to bring the code to a file, to a graph. And then your rules, so the rules, the way I was seeing what you were describing is that feels like a rules engine that sits on top of a graph that is already the representation of the source code. You might actually, what might be actually worthwhile is showing, that proof of concept that we developed. Can we actually got that in live anyway? The version that you can actually see almost the creation of the SL.
So I think he's talking about the data viewer, Stephen.
Yeah.
Yeah, I can bring that up. I was just trying to find my DVL spec, because obviously there's a lot of rules and things in there that are kind of pertaining to the same sort of thing. Yeah, give me a sec. I'll run that up.
So Dennis, one of the things that that came to mind, for instance, is when we export that our intermediate representation, that's done in, for instance, XML. So would your thought behind it be somewhat producing an XSD that validates that XML that we generate? That essentially would then have your rules that map to individual parts of the file, but then those XSDs, the actual restrictions and the conditions against them, are extracted from the ISGs.
Yeah, well, I think it's an interesting thing because like, unless I haven't looked at where you actually got, when you get to the XML, like, do you have a version almost like that is dirty? Do you have a version of that object model that is almost as close representation of what you grab from the file, that which is where you apply the rules on?
So that's what that was part of the, I think, a session or two back. Stephen had attempted to switch off the validation pause, which means that you would get the representation untouched, so almost as it comes in.
Sorry, Ibrahim, or actually, can you mute Ibrahim? Because I think we're getting some, sort of some child noise from there. Who is the host? Or Ibrahim, could you mute? I'm sure.
did that work?
Yeah. Okay. Cool.
Oh,
yeah.
I'm Adam.
Yeah. Great. Sorry. All right, Elvin, go on.
I can't recall where I was. Let me just.
So we talked about
Oh yes.
You build an XML representation, right?
Yeah. So Stephen carried out an experiment where he was basically attempting to switch off the validation phase and the sanitization phase prior to exporting that intermediate representation, which means that you do get something that's a representation of the original file that comes in pretty much, because we've not yet started manipulating that or changing that. So we could get that. The idea when we were doing that was so that we can actually generate the test data for the ISGs by sort of intentionally corrupting the file in certain places, which means that now you've just produced a test set that has coverage of that ISG that you can then run through for rules such as cleansing and verify whether you've actually met that condition or not.
Yeah, that would be really cool, right? So if you can use the object model, right, to then go and insert bits where they're not supposed to be, or where you can manipulate it, then yeah, that would be a much more effective way of doing that.
But the other thought I had was, imagine a scenario where you've actually got an XSD that will validate that XML. So then any file that you process, if you've got that XSD, it would actually pinpoint you to the location that you've kind of infringed in that ISG itself. So you basically have something that will check against every file that comes in if you define that XSD up front. The XSD essentially being the rules from the ISG.
Yeah,
I think we
Go
sorry,
on.
I was going to say that's something we actually sort of toyed with PDF, wasn't it? Because of as a alternative way of doing PDF
Validation, yeah.
validation, we were going to say, well, we get an XML of it. Once we get a cleaner version of the current one, is a little bit too verbose. But yes, that was something played with there. But yeah, we could use that as an intermediate way of testing. I've got that data up in a minute if you want it.
That basically means that anyone externally that wants to use it can utilize Glasswall to verify if what they've done to a file actually matches the ISGs or where they've gone wrong, if that makes sense. So you almost have Glasswall running as a validator of the ISGs.
Yeah, well, okay. So I guess the only question then is that, I'm not sure the XSDs, you're going to have enough, capability to describe some of the rules, right? I think some of them you can, but others you will need a proper rules engine, right?
Not sure, not entirely sure. Firing from the hip, of course.
I think we can probably cover quite a lot, but yeah, there might be some iterative things that are a little bit more difficult
because we certainly export in our XMLs all the way down to pretty much the binary content, right? So you've got access to all of that. You've got access to the sequence in which things come in, because that's that representation. So you can validate sequences of things, or whether things are in there that shouldn't be in there, etc. So I'm not sure what other sort of rules we wouldn't cover in this scenario.
Well, I think, I could see like a number of the validation, a number of the things that you got to do, right? Because so what you're saying is that you can create an XSD, right, for the
so if I give you an example,
created from the file, right?
Yep. So if I give you an example, the Office XML file formats, because they're XML, they've got corresponding XSDs. So our validation actually complies to the validation that's defined within those XSDs. Do you get what I mean? So in that particular case, because it's an XML, our validation is actually carrying out something similar to what they would do. I suppose there are probably a few bits where we do a bit more, we restrict it a bit more, but generally speaking, that's already how the Office formats kind of come in.
Yeah, but that's just one part of it, right?
Mm.
And but again, like having writing those rules in XSD is going to be horrible.
Potentially, yes.
Well,
unless you can figure out a way to sort of generate them. Because for instance, the way we've defined some VAR rules is we've actually parsed the XSDs from Microsoft and had them translated into our data validation language, so DVL. And then we've applied those DVLs to our binary data definition language, the BDDs, and then that's been translated into C++.
Yeah, and that by then is the rules, right?
Mm-hmm. So we've been able to programmatically go through that entire loop.
Mm-hmm. Yeah, interesting. Really cool. But I think if you go back to the stuff that Wolfie was showing, is that there is value in having, almost a graphical way to represent each of those rules, right? And I think what's interesting is that you do need an XML or an object representation of the file in order to do that.
Mm-hmm.
And Wolfie, my point with that tool you were talking about is I think that tool is interesting to determine if for cases where you want to search for binary strings or you search for a specific pattern, right? So you could have a case where you put a signature of a payload in lots of different places, and then you can actually use that tool to just search the final binary and saying, is this thing still there?
Mm-hmm.
I mean, yeah, or determining also if certain patterns are out of order and or are where they shouldn't be, it also would. Oh wait, for the Yara, sorry.
Yeah.
Or determining I mean, it could even be useful, actually. I was thinking about how you could do run frequency analysis, because what if you really want to break down simply the ISGs, and this was part of what I was thinking about too, but more for, you know, I guess what you know, it's not really like the engine of it, but like for, you know, I was thinking about for how it would run, but also if you really wanted to break down the ISGs, doing some sort of frequency analysis and removal of excess word usage, figuring out definitions for the main words that are actually important, and then having it search through and look for those words so that it actually can then adjust the language itself. It seemed like something that would be really useful. If that makes sense.
Yeah, I think I'm getting where you come from. I think our biggest thing is that, and this is, perhaps I'll just bring out this little bit of demo data in a minute, is that we've kind of built a lot of this already, and therefore we could effectively run tests on our own system to bring up just prove the little changes that are being highlighted and show that we get the result that's expected. That's probably, so it's kind of that yes, we've sort of built it from some generated rules and from handwritten rules, and we believe that we've got a superset of what ISGs dictate, and it's really kind of a case of trying to prove by inserting those sorts of faults into dummy files that we actually meet the criteria of it.
I see, but only for the specific type that we were able to experiment with on the glass wall side, or do you have more that are actually done already? Because there are a lot of ISGs.
Yeah, we've I mean, our systems have probably got, you know, in excess of several thousand tests per file type that we deal with, and certainly sort of reviewing, you know, ISGs. I'm seeing sets and things in there that go, yep, we deal with those, we deal with that. Now, it'd be nice to sort of build some sort of proof of that, but I think it potentially can boil down to generating test sets that have got those specific issues in and proving that we react to them within a suitable message, and then tying those up somehow to the ISGs. I think that's the sort of feeling I've got about it.
I mean, the same sort of process with the actually the real process with being able to iteratively go through and change the chunk order. I mean, that's pretty much all you would really need initially, you know, to get started with that. And then I guess seeing what you could introduce with more random or other, you know, introducing other elements as well.
But I think that's what Elvin was mentioning,
so
that
dictionary.
we could use, you know, I think that there's a, you know, Elvin, if you can have access to that first pass of the object model that is literally as close as possible with the original, then you can rewrite that. You can use that to rewrite bad stuff, right? Non-compliant things.
Correct.
Right. I mean, I've got. Can you see my screen here?
Yeah.
Okay.
Yeah.
So there's a PNG file here on the left, which I forget what it was. Some small little picture. This has been through our product and exported, and the export normally breaks it out into a zip file, and I set it into XML mode, so it let me load it up in a more readable form. This produces there's a lot of noise in these at the moment, which we're looking to strip out to make it a bit tidier to look at. But the fundamental thing is this has gone down through the PNG file, and it's, as you can see, it's grabbed the header, it's identified the chunks, and it's identified the values in each of the specific elements. There we go. So that chunk is broken down some palette entries, and it's got the values in there. Now, what I did is close that and go back up. they made a modified version of that, so I copied that, and if I do a compare, then you'll see it's got the same XML file, but then I got down to here and I made a copy of that PLTE chunk, which was one of the items listed in the ISG that's got to be a unique entry. So what I then did, as I say, I ran a import validation on it, and if I grab the report, you'll see that on the modified PNG zip file, it's bounced up saying there was only one PLT allowed, and it applied a remedy to obviously potentially remove that. Whereas the other one, the original one, is happy that it's clean. So this is sort of the example where there's a rule specified in the INGs. We've obviously already seen that in the specifications and written a rule previously that picked up exactly the same thing. So I feel there's probably a lot of occasions where if we can construct a useful set of test files that test those particular elements, you know, we can do a proof against our own system and say, here's the same result coming out. Yes, you've got a problem correlating the way we name things or whatever, but we can sort that out either through some sort of cross-reference lists or maybe annotating some of our internal messages to actually reference the ISGs that errors that they are particular about. Clearly, some tests are a little bit trickier because ones that say this one is particularly quite a nice, neat one. It just says this must be unique. We've already spotted that. We already error if there isn't a unique one, and remedy it. Other ones are a little bit more vague, where they're sort of like, you know, these things, you know, particular chunks must not be in the places that they shouldn't be. Well, obviously they can be in, you know, hundreds of wrong places. You could only create a few examples of putting them in the wrong places and checking that we inherently either reject the file or rearrange it or whatever.
That's kind of what I was thinking would be more of an iterative process, because all you're doing is you're checking it against the standard over and over again for each location.
Yes, but this is kind of the fairly sort of normal for a lot of regression testing on like control systems that I've worked on in the past. You know, there are things where you have to say, well, there are potentially millions of ways that this could fail. All we can do is pick a useful range of likely places that would be a problem and make sure that we spot all those and deal with them sensibly. And sometimes that is a case of, you know, maybe that's 10 or 100, or, you know, if you're doing like really safety critical stuff, maybe thousands of random places for a particular fault or a particular error signal in the wrong place to prove that your system deals with them all. And you work on the basis that, you know, statistically, if it's dealt with all those random ones, then all the potentially infinite number of places it could go wrong, you hopefully it covers. But
I can see how that would be, because I mean that is pretty complicated. I was just thinking of it as kind of how the process would be performed, maybe not necessarily the bulk of how that process would, I guess what that would take for it to work, if that makes sense. Just how you would go about it. And yeah, I mean the randomly checking is probably,
I'm sorry, I was just saying it's one of the perennial problems in testing of this sort of stuff. It's how do you, where you have such a huge variety of potential inputs, you know, how do you know, get those, you know, what is technically called, you know, those equivalence classes of saying we're going to take like this one particular sample and we think it's say it's equivalent to all these different things. No, you have to be very careful that you don't end up sort of doing massive amounts of different tests where actually they don't actually apply a lot of value, you know, and actually take a huge amount of time. But you've got to still make sure you've got that minimum coverage to kind of be comfortable that you've the thing's working as you expect.
And
but that's what I like about the ISGs, right? Because, you know, every one of those entries, there's a reason why they're there, right? So at minimum, every one of those entries need to be tested. Now you can recycle some tests for doing that kind of stuff, right?
Something as a point I was actually going to pick up because I've been looking through the JPEG ISG today, and the interesting thing about some of those is that when they list and some of the things that you should actually do, you've actually got sometimes choices of how you behave. The PNG is a really, really good one because it gives you a list of validations and it gives you some very precise actions to take on particular circumstances.
Yeah.
Whereas the JPEG one, quite often you've actually got a number of different things that you could potentially do, and they seem to be sort of like alternative actions that you could do in the similar circumstances, which is quite an interesting thing because you've got to think about, because it may be that you, as a and our software, it may take one of those particular approaches, so the other ones become not applicable.
So the one thing I was thinking is that it is important that none of the parts of the file are identifying it or allowing it to be used as a different file. So that's the one thing that I could imagine you could actually figure out how to really test for that maybe wouldn't 100% be covered in the ISGs.
Are you talking about one file masquerading as another?
Yeah, or having aspects of it that could function as another, basically testing against the rules that are unique for a specific file type, so that they're not actually registering or showing up or acting as the file type that they are not.
Yeah, but I think the way we do it, right, is we do a file type detection based on the file structure, right? So we by the time we do the analysis, we know really well what type of file it is, right?
Right. I was just thinking about how you would check, I guess, most effectively for keeping them from having aspects that would be dangerous. These are those parts that would be dangerous would be relating to another file type.
Yeah, I think I was just trying to dig around, trying to bring up some sample information. This is on a JPEG. This is our binary definition. So this is effectively the specification for the structure of that particular file type, which if I sort of rattle down to the bottom, it simply says that a JPEG is comprised of this starting element, any of these possible optional segments, and this ending element. And then each of those is then defined in their own sections here with necessary markers to sort of say, right, that particular field must equal that value. These must be of that particular size. This is allowed to be a large number of bytes as long as it sort of effectively is looking for a terminating condition there. So this sort of stuff is used to do the initial reading of the file into our tree structure. So there are a number of set rules and markers and things that if they don't match, then it will simply drop out saying, no, this isn't the binary file of that type. And
right.
then,
I guess I was just suggesting that certain of the rules be introduced as ways to actually set up a test file, for instance, and adjust it based on the rules for other file types versus just randomly doing it. That way you're actually checking for something that could be a consideration as far as like, this is supposed to be in this type of file type, it's not supposed to be in this file type. I know you're getting it initially from that thing that yes, this is this file type, but how close is it? And is there, ever kind of a crossover that's not supposed to be there?
Right. So you're saying if there was a slight corruption of this that had the marker in the right place.
Yeah, and it seems like that's
and had a block of data that is low. Well, I mean, that is a fair point. I mean, the sort of thing we then, we have additional validations that would then perhaps do, well, that one doesn't have anything, but we would then have additional test elsewhere that would look for things.
I mean,
But yeah, it is a fair.
Part of what, yeah.
Sorry, Karen.
It just seems like that's kind of a part of what the ISGs also lean towards in a certain sense.
To actually inject in serious faults and just prove very specific types of corruptions. So whereas our general philosophy is to check that it actually conforms to spec, and if it does, it's fine. But
yeah, but
it's where there is if there's
like that. Yeah.
Sorry, sorry. Say that again.
I think it gives a brief moment and then goes back. I don't know. Maybe it's cutting out here. But yeah, so making sure that there's not like the possibility of a cross chatter, I guess. I don't know how to say it, but like something that would be in there that would match up with a different file type that is not the file type that it's supposed to be at each point. So basically using the other rules to create a test set, the rules for the file types that are not the file that you're testing. You basically have a dictionary made right there.
Yeah, I think the granularity we tend to go down to, it would be extremely unlikely that a completely different file type would be accidentally mistaken for it. There's certainly potential that perhaps some of the smaller elements you might be able to create something that.
I think what's missing here is that there's actually three levels, three different layers of validation in the system at the moment. The one that Stephen's presented right now is sort of the rules that allow it to, you can almost see it as blocks of containers that allow it to form that particular file structure. So that's what he's showing you right now. It's an additional set of rules that goes through the individual fields within what he's got in front of you. So for instance, there'll be a rule for that marker in a separate file that says this marker should contain just this, this particular field should contain just that. And then there's a third layer of rules on top of that then goes through and looks at the relationships between certain structures, certain objects within that tree that then tell you it should be in this particular order, this particular range. If this value has X, then a value elsewhere must have Y, etc. So what Stephen's trying to say, it's going to be extremely unlikely that you can have almost polyglots in a system like that.
Okay, that makes sense.
You do have. But I mean, the other issue I was thinking about this, Elvin, is kind of associated. We've got the polyglots, but and that to me is like is a perfect example where, we can have a PNG, and in a number of these file formats, you are allowed, you do have a certain amount of white space or latitude, so you could insert a complete other file type within there, and then it'd be interesting if you kind of then scan it, for those both different file types, kind of what it comes out.
So the system at the moment, Greg, only knows how to work against what's defined. So anything unrecognized is basically an unknown object. It just throws it completely out. So if it doesn't fit into any of those definitions, the DVLs, the BDDs, and that cross check, then it gets dropped out of the file.
Yeah, but if you imagine, say, some of these, if you have something, PNG, we know that you can insert white space into it or other stuff in there. Yeah, actually, I suppose if you put a complete other file in it, it's going to pick it out, isn't it? Well, you'd have to put it into another chunk or something like that. Yeah.
Yeah. So even when it comes to padding, for instance, some people try to insert complete objects within the padding, but again, there's going to be a rule there that says, can you make sure everything in here is zeroed out because this is just padding. So it's those scenarios get caught out. They get picked up.
I mean, that's in relation to what you're saying there, Elvin. I think in the PNG spec, there is recommendation in the spec that there's where there's padding, we do strip it out as well. I can't remember what chunk or where. I think it might be at the end of the file. And there have been cases where we have come across files with extra unnecessary padding, and we do strip those out according to the spec.
Yeah. Yep.
Yeah, so it does seem like that's kind of the intended, or the intention behind the what's listed there in the ISGs.
So unfortunately, it's the old version of this tool, but It just gives you a quick overview of the structure level that we break a real file down to. So those rule sets I just sort of showed you where the structural information was, that's applied to the file and it's used to create that tree of structures. And then with each one of those structures, there will be the individual values that are part of the specification. And so when we construct, we make sure that these are roughly the correct units as the test that we can do on each one of those. Then we will validate each of the values within them. And then as Elvin says, we have a callback mechanism that iterates down through the entire tree, checking that, you know, if this particular field here says that this should have 4 pallet entries in it, then it will check that. I don't suppose it does, but or if there's a checksum here for these groups, you know, all those sorts of cross relationships.
All the way down. All the way down to the order in which things are permitted as well.
Yes, yes. Which is annoying when companies change that in their file formats, isn't it?
Yep, that's our big bug at the moment, isn't it?
Yeah. Microsoft decided to change their mind on that one. Yeah. Thanks, guys.
Yeah. But you also have cases where, you know, when somebody saves into a file format, they take liberties, right?
There has been certainly, occasions of sort of third-party file writers that haven't quite understood the spec exactly correctly and have done things in a slightly different way, or even official versions. You know, we find sort of variants within the specs. They might say that at this version this field is present and this version that record is present, and then you go, well, hang on, this particular record's got these extra fields in, and you find out that, well, they did sort of sneak out some modifications and never put them into their spec officially, or they pad data on the end of something. So something says this record is X to here, and then there's another chunk that sits afterwards, and it's valid, it's in the specification. So you have to know that you can cross-check to there, then you have to look for a structure of a particular type, and then the next record can start. But that's an option based on some field somewhere else. So there's lots of lovely little cross-references like that. So yeah, I think the fact that we deconstruct this way is pretty important first, because it is a way of saying, right, this does conform, or it's got, if we got, you know, like this one here, that we've got a rule that says there should only be one of those, we're testing for it. If there's a rule that says there should be an odd number of something, they're the sorts of things we would have in there. So I brought up the validation rule list here that, let's say, covers a lot of the common things, and that can reference back to structures within the tree where necessary. It's only the third level where we do the callback in order to deal with things where you have to count something, or you have to check an iterative number of structures within the tree in order to do a cross-reference. But if you can get back to a particular thing in the structure, we treat it as a sort of an X-tree style path.
But
you can actually forward and
actually if you go back, Steve, if you go back, that conversation we had a couple of days ago, right? So those are cases where you could have files that don't match the so don't match the spec, right? But if they are ISG compliant, we can still consider them to be safe.
Well, my hope is that we will find that what we have in terms of our specification check is actually a superset of the ISGs, but obviously that's something we want to prove.
Yeah, you know, what I'm saying is that when there's times where we'll have to allow things that are not spec compliant just because the industry have decided, right?
I guess what you're trying to say is basically in terms of we're a bit too strict, which basically means that we stop some files from going through which are technically harmless. They've just not been constructed very well. The ISG is a mechanism to kind of permit some of that through, so almost having a less strict option.
Exactly. Right, and but in a way that it's very conscious, right? And look, there's some insane stories of Microsoft, right, having to make all sorts of curveballs, even on their operating system, because, for example, when they introduced some security measures, right, on the OS, they found that some of the most popular tools in their product actually did insane things, right? Then they realized that if they push this fix, they will break the entire, user base. So they would add specific fixes, sometimes to the kernel, right? Sometimes to the OS, to take into account that. The question is that you don't want to make it a general backdoor, but if we can make it so that we know that, for example, this type of files or this type of printers or this type of variation occurs, we can allow that relaxation of the spec, or make a note, right? Say, hey, by the way, we couldn't validate this against super spec version because we follow that, but actually when we apply the second batch, it made it okay because it fall into that still ISG compliant, but not 100% spec compliant.
I mean, it may be something we can do with the fact that we a lot of our tests, we have them identified, so there are ID numbers against things. So it may be something we can do at that level to simply say when this particular failure occurs, if we're saying we're going to be less stringent about it because it's not outside, it's outside of the it's making a spec failure, but we can allow it through because under the ISG regulations it's not one of the critical areas. So we may be able to control things at that level.
So the way I understand it, does you're essentially saying that we could use the ISG rules as almost an engine for classification, right?
Exactly, right? Because this is where if you go back to that almost slide that I put in, right? On the last session, do you guys have those definitions of facts on the last session? Not in this. Who's actually Elvin?
Let me try and bring it up. I did have it.
Do you have it? Yeah, if you would bring it up, right?
Yeah, carry on talking while I try and bring it up.
Yeah, I can.
I did mention about using the ISGs for classification.
Then I just send you the link.
Presentations. It was, I think it's a very powerful way of doing it, actually.
I'm going to have to dip out at this moment, I'm afraid, guys. But
okay, cool.
Good
no,
chat.
thanks, Steve.
Cheers, Stephen.
So yeah, I think Elvin, that's kind of exactly my thinking. Right? My thinking is that the ISGs, right, and let's assume that is the ISG's latest version, right? This is not the version published by the NSA because maybe there's some gap. Let's say the latest version of the ISG that the community is providing feedback, and we keep adjusting, right? That should be the definition of security, right? So if you look at this from a risk point of view of the files, right? Actually, if you go up one slide, yeah. So if you look there on that thing, so you could say, look, the ISG should cover all elements of a file that has security side effects, right? Are we agree with that?
Mm-hmm.
So if an exploit is done using a method/technique not covered by the ISG, right, then that should be a vulnerability in the ISG, right? So that, by definition, that should be, right, a scenario where the ISG has a blind spot that needs to be fixed. Because in proxy, it means that something has happened through a file that is ISG compliant, right? And it had some side effects. And some of these could be introduced by a new version of a file format that introduces, new things, right? And then we say that if a file is spec compliant and ISG compliant, it should be safe. Because the other thing that's interesting here, right, is if you look at a file that is spec compliant, right, a file that is spec compliant, we know that a lot of them are not safe. Like, for example, macros, JavaScript, metadata, they all comply to the spec, right? But the spec has dangerous functionality, right? So the ISG actually brings the spec, right, more in line to say, here's the stuff that we don't want to be done. Now we can say that a file that is non-spec compliant, but is ISG compliant, should also be safe. Because this is a file that, for example, or maybe a program that didn't save accordingly, or they, like you guys were saying, sometimes they didn't follow the spec correctly, but they still created a safe file. So that should still be safe in that way. And then we have a file that is spec compliant, but non-ISG compliant. By definition, that file should be unsafe.
Well, I think this is what I was trying to say the other day. I think what we're trying to achieve is a bit like what we did in the cloud, where we introduced, where we were too strict and we wasn't letting things through and making it very heavily admin control biased, where they had to keep flicking to allow what were files that were relatively safe through, but we were blocking them. We introduced a threat assessor engine, basically reaching out to virus total to decide whether something was pretty much safe to go through. And the threat virus total was like the ISG kind of engine to decide whether we can safely let something through rather than block it so stringently. So to me, this ISG is a bit like the virus total equivalent.
Yeah. So if yeah, but the problem is that virus total. No, I'm not sure that's correct, because virus total is giving data from multiple engines, right? And fundamentally is looking for bad stuff, right? Where what we're saying here is that we have we have a file that in all of our ISG tests has succeeded, but there's parts of the file that are not compliant with the spec of that file.
Yeah, I agree.
Dennis, effectively what you're saying is this is the fourth layer of validation. So we have the 3 stages. This is a fourth one that maps things that can happen within a document to specific vulnerabilities.
Yes. And I think it's interesting because you almost can have, well, I guess depends on where your layer is, right? Because this could be the third or the fourth layer, depends on which ones you break, right?
Yep.
Because actually, if you go to the next slide, right, what you then kind of have there is this idea of Vinh, could you go to the next slide?
Yep.
Where you now have the risks, where we could say that there's a high risk of a file which is non-spec compliant, right, and non-ISG compliant, right? In fact, I'll probably say medium to high risk, depends on what it is, where you have a spec compliant and non-ISG compliant.
Mm-hmm.
Then you have a low risk, which is non-spec compliant and ISG compliant. And the best one is when they comply with the spec and the ISG.
Yep.
And I think what we'll find, and this is where, again, machine learning or lots of files analysis, we might find a lot of files are non-spec compliant. And look, we can even have a manual process here, or we can even have a process where we whitelist every one of those non-spec compliant. In fact, we can even have a path to add to the ISG to say, by the way, we see this in the wild, right? So we actually want to add a section to the ISG, which is non-compliant parts of the spec. It's like, we see people doing this, but at the moment, our analysis, our security analysis, is that there is no side effect of that.
So is there any crossover with this, with what we was trying to start to embark on, which was a machine learning engine to decide these risks?
Yes, but I actually think that, this actually gives you, right, a very interesting way. Instead of doing machine learning, we can be very explicit on what's ISG compliant and what's not ISG compliant.
This is definitive, isn't it?
In fact, even ISG compliant, when we really look at it, you probably have high, mediums, and lows, right? There's probably things in ISG that we all agree, no way this should happen. But then, there's other areas in ISG that, they have the check and validate, or, take a look at this, which is still something that it's a bit weird, but it's probably not something that is worth blocking a file.
The other thing you get from them is potentially it's if we could also pick out this. I mean, I like this kind of something simple as this because it's kind of really fake. It's kind of really clear. But the other thing about it is that the ISG gives you, if you look at some of the summary tables, it gives you when you're not ISG compliant, it's what type of risk that you're actually associated with it as well.
Yes, and I tell you what, the output of this analysis would dramatically improve machine learning optimization, because the quality of the data that you get, for example, by feeding into machine learning the ISG analysis versus feeding the machine learning the spec analysis, I think you find that the noise in the ISG analysis is going to be way, way lower.
I mean, it could be like an extra feature to add to the algorithm, which could potentially then help determine the risk. But and it would be interesting to see, because you could also calculate the coefficients and see how important this spec compliant or non-spec compliant is in determining how important it is to determine whether a file is malicious or not. So it would be interesting to play with it, because then by using machine learning, you could actually say how much this is like applicable. Like it could be a test for this.
What do you mean a test for this?
So for example, if we take like a set of good files and we take a set of bad files, and we add this as a feature. So for example, if there was some malicious files that were at the same time non-spec compliant, then that could also obviously prove that, you know, if this is non-spec compliant, then
are you basically trying to say that you could utilize this to basically identify the characteristics that make up a bad file?
Yes.
Yeah.
Yeah.
Well, yeah, because look, that is what the ISG is. It's like, look, you know, isn't it?
That
right?
that could just prove it. Like that would be like a good way to kind of scientifically approach it and say, like, look.
The ISG by definition is that, right?
Yeah.
And actually it would be really powerful to be able to map that to known piece of malware, right?
Yeah,
so
exactly.
we can go back and say we've seen malware, and that is something that will scale a little bit, because you know there's a little bit of maybe even manual work or research work, but I would expect that the variations of that wouldn't be that much. You tend to see patterns of exploits, right? That we'll know that, you know, the macros in JavaScript are the most obvious ones, but when you have exploits that target specific sections or specific variations of it, I think what we'll find is you will find that by analyzing the data that we get from the ISG analysis, or the files that don't make it to the ISG, they will be a lot more strong, the signals on the level of maliciousness of those files.
Yeah, but you can, with machine learning, you can actually get like a coefficient, which will give you like a direct correlation with that. Like if they're like non-ISG compliant, then you could find that the algorithm, you can just print out a coefficient which will give you like a good strong correlation with the maliciousness of the file, for example.
Yeah. But this is, if you think about it, right? You know, and you know, Elvin and Greg and team, right? The ISGs should become our blueprint, our common language between us, you know, the clients, the partners, the integrators, you know, the file, you know, the companies who create file parsers, right? That's the common language, right? And we have common test suites. We have, you know, valid ways to test it. And then once you've got that in place, it just becomes a case of having better coverage, right? So it's like improving the test coverage of our ISG's tests.
Yep, and I guess it gives an explanation as to why we do certain things. So for instance, a lot of people struggle to understand what the sort of issues or the sort of remediations and sanitizations we do are, that maps it to something that makes perfect sense.
Yeah.
And to recap on what you said, Dennis, as well, if you stick in the ISG rules in JSON and refer back to the CVEs, or then that gives it even more stronger backing as to why we do things like that.
Yeah, but also like what is a bug, right? And what to focus, right? And what not to focus, right? So, you know, so if you have, you know, a file that, you know, it doesn't, you know, a file that, for example, doesn't pass the engine, or the engine lets go through, that breaks the ISG, that's clearly a P1 vulnerability for us, right? A file that passes the engine, but it's a spec that is not covered by ISG, right? Then there's a case of reviewing it to see, you know, is there any side effects that are problematic? But the risk of that file is low.
Yep. And that kind of lends itself to putting basically a switch around every single validation rule we have, which basically then gives someone the control over what they want to let through and what they don't. Because as you say, if it's compliant to the ISG and there's something else that's been thrown out, you could say, okay, based on that, it's a low risk. I'm going to switch this thing off and still validate and regenerate my file. If that makes sense.
I have a question. If we work against the ISG, if we find something that the ISG doesn't cover, but we do, and we want to contribute and ask the ISG to update their documents, how fast did they turn around on updating the ISG?
Well, that's one of the things we're going to find out, right? But that's where sorry, go on.
I'd imagine that the reason that at the moment it doesn't seem like they update it frequently simply because they don't have anyone else giving them that feedback.
Yeah, I agree with you.
I mean, some of these, I mean, if you look at it, even though some of these documents might look they've been updated in 2017, mostly it was just about changing the fonts and some of the branding. So probably with some of these, I suspect there are new exploits that aren't covered, or potential exploits that aren't necessarily covered as yet in these ISGs. They're a good baseline, but there might be other stuff where potentially from some of the stuff that we see, we can go back and say, yeah, you know what?
So it'd be in our interest to try and tease these out as fast as we can, so we can actually contribute.
Yeah, absolutely. I mean, I you know, this is kind of the baseline thing, and I think we're going to find is that if you go through and check it, there will be other stuff. There'll be other potential exploits that, you know, that could be there, and that's one of the things, you know, where us going against the specification has some extra values to just on top of what says in the ISG, because the ISG doesn't, you know, as we said, doesn't cover everything, and it's
but
just a matter of knowing where the balance is.
No, but it should from a security point of view, because that's the concept, right? Yeah. So, but the other thing that we need to move the conversation to, and that's why I want to start, you know, the idea of how to scale and how to test, is that this kind of guidance doesn't work as a PDF, right? You know, like basically that has to be a graph, that has to be a database, right? So the conversation we should have on the community is where we host it, who contains the master, who is like the kind of the quality gate of this. Who, you know, should be somebody, but the way to do this is like DevOps, right? Like this ISG, it's like a vulnerability, right? If you find a blind spot in an ISG, you have to treat it as a vulnerability, right? It needs to be identified, it needs to be released, and then it needs to be distributed to everybody that's supposed to be enforcing that ISG, right? It's like a signature, in a way. Yep. So it has to be a graph, right? The point of this is that we need to figure out also as a community is where is the best place and where should that happen, so that, you know, you have a regular, it's like policies, right? You know, you could have a quarterly or yearly updates of the ISG as that document, but again, that document should be programmatically generated from a dynamic set of data. It shouldn't be, you know, a Word document, which is inconsistent, and you might even have mistakes, right?
And I think this kind of circles back to some of the discussions we're having about how you kind of generate a series of rules from the ISGs that you can easily implement.
Yeah, absolutely. But Elvin, what do you think of this, you know, ISG center of gravity?
I actually like it quite a lot, actually. Yeah. I'm definitely in favor of it. I actually agree with it being, to me, it almost seems like something that should sit on its own, and it can be used by anyone just to verify whether you're compliant or not. And from our perspective, it lends itself to a separate service that you send your files to after it post class wall.
I think
for the file verification.
Yeah, for the verification.
I think it also gives us good direction of how we work against this spec as well, because sometimes we do scratch our head sometimes on when we've been given options in the spec.
This is Martin. Can you hear me?
We don't know which way to turn. Yes, we can, Martin.
Yeah, we can, Martin. Yeah.
Oh, sorry. I was going to say my only contribution to your question, Dennis, was I wish we'd known about these a while ago.
Well, Well,
I mean, I agree with Elvin. I mean, they're a great, they're a great source.
Well, they've been around for a while, right?
Yeah, I know. That's what I mean. I wish we'd, you know, known about them because we just didn't.
I'd say I wish we'd acted on them sooner.
Yeah.
Well, I think the problem was we was being too cautious, over cautious. I think.
Overcautious.
As in, like I said, like upstairs in the cloud, we're using an engine. We're over cautious, and it's caused us problems in some cases.
I love the fact that you still call it upstairs.
Yeah.
I like the way you say you.
Well, it's because I've seen both sides of the world. I've been in court where we've been so overcautious, and then upstairs where we've taken the engine on and used it in anger, and we've had complaints from customers saying that I've been overcautious.
I like the phrase "in the cloud" as well because that's got connotations to it.
Yeah. Yeah. So
I definitely like the idea, Dennis.
Yeah, and look, you know, for example, like walk this a new file format, right? So let's say you have a new file format and you want to analyze it. If you think about it, there's two parts of the process, right? The first one is, can you build some BDL a model that you can access the bits programmatically? But the second immediate question is, what are the parts of that file that have security implications, right? And then if that's the only ones you address initially, you might actually have really good coverage, right? So you could have cameras that are really good ISG compliant, but have very low spec compliant because they don't cover all the spec, but they check for everything that we today know that is dangerous on that camera, or sorry, on that file format. See what I mean?
Uh-huh.
And what that also gives you is that focus, right? What do you focus when you're adding support to a new file? Like I think there was this example of these massive, for example, image files that they were talking for us to process. I think the main thing they were worried about was the geolocation, right, of the files and some metadata files. So you could argue that, look, that's what the ISG should cover, right? And it's better to have an ISG that covers what we know is dangerous about that file than not have an ISG and not to cover that file.
So I haven't looked, but you're saying that the metadata being removed off of photos is not on the ISG, or?
No, it should be on an ISG, right? What I'm saying is that there's some file formats, I think, from satellite data, right? That, clearly, right, it's, the location of the image might be programmatic, right? Or the GPS or some metadata where it comes from, but that might be the only thing. And it might be a very complex file format, but actually the only thing you care about initially is that data. And then you might even look at that and go, well, there's tons of places where metadata could be inserted, but then the threat model of it will go, yeah, but I don't think the satellites are going to introduce bad data, right? I mean, so you can do, in fact, the ISG should be driven by a threat model, right?
I mean, there are definite things I think about that. I just think of a recent example where some of having the ISG, would have helped with some of the design decisions that we potentially make as well. I think of a recent example we're thinking about with PDF. We argued for quite a while whether we should make a change or not. We decided not to. And I've looked at the PDF ISG and couldn't actually find anything about that particular change. So you potentially say, well, actually, we probably then made the right decision because from a security point of view, they're not covering it. It's not a problem.
Yep.
Although it did annoy that particular customer, but.
Cool. Any other topics you guys want to cover? I think one question is what happens next, right? So I feel that we really came a long way, in this week, and it's kind of what I wanted from this, but what do you guys think should be the next steps?
I personally think it's experimenting with some of the suggestions that we've had over the course of these meetings and trying to actually build something from it. So certainly internally at Glasswell, we'll definitely be doing that.
Yeah, and start to publishing those data sets, right? And start to, use this kind of more in a public way, and then see if we can, reach out and get other players to participate, right?
Precisely.
I'd be interested to at least be able to look around and see what you guys have inside of there, because it looks nice. And I'm interested how all of it functions. I don't know.
Well, there's a couple of open source. I remember there's a couple of CDR, a couple of open source tools out there, right? So we can always use that as the benchmark, right? As the base, because that would allow a number of these things to occur, right?
Yeah, I think the objective is always to create something that can be shared with the community and used by everyone, right?
Yes, absolutely. But also because we want to leverage the community, right? We want to share, but ideally we will benefit from the community, right?
Yeah.
Like put it this way, we know individuals that are super, clever and super, knowledgeable in this area, that at the moment they have no way to communicate, right? They what's the option? Is to go and change the ISG? Come on, that to them must be a hell of a process, right? Can you imagine? And even if, please, right, even something as simple as when you publish an ISG, a diff of what changed is absolutely critical, right? Because there's no way, if you change an ISG in 25 places, unless you have a diff of what changed, there's no way you can go back and detect those changes, right?
Yep.
So there's tons of logistical issues that needs to be addressed for this to really be operational.
Yeah, that makes sense.
I mean, it's whether the thing that you want to measure to against is the ISG in the document, but it seems to me that as we've discussed, they're just not the right format to kind of hold the information to make it easy.
Well, I suspect that anything we do, Boyd at least would have a use for, right?
Yeah, I can imagine. I can imagine a lot of the CDO find it very useful.
Yeah.
I almost wonder if, because of the nature of it and how so many people could actually use it, if they would prefer almost to do some of the work themselves versus having, versus like a third party doing it and it not being. I don't know. Someone would have to talk with them about it if it was to be something that really was out there, and just see, what kind of, because I'm sure that they would want regulations of some sort there. They would want to make sure that it's done well and that it's not introducing things.
Well, now you hit something which is really powerful, right? Which is the big elephant in the room is that, the file makers should be part of this conversation. Right? Like you should have the people that actually wrote the freaking original specs and actually wrote the main parsers, who actually wrote the main specification, who actually control the specification. They're the ones who should be, helping and updating the spec, right?
Right. I wonder what that would actually take. That would be interesting to find out.
I mean, for me, I think I always kind of look at this and I always feel that one of the really, really potential intensive parts of the exercise is to create the actual data, or having a good set of data available for people to run against. That to me is I think is one of those areas that, the more people that can contribute to that, the better. If you've got something, say, okay, here's another example of something that that if people can contribute, additional samples of a particular problem where something's not specific, either is not compliant or it is compliant. That to me is kind of where you get it really starts potentially ramping up the strength of any validations you do.
Has anyone tried reaching out to them about it?
I think
That's
that's
part of what
enough.
that's part of, well, that's part of what we're trying to do with this summit, right? And I think we probably want to do another session, you know, in a couple of months from now, where we actually can point to these sessions, right? And then, you know, get them more involved. But these things always take a long time to find the right individual, to find the right forum, to find the right, you know, kind of environment. It always, you know, it's not a trivial exercise. But yeah, it is hard because, you know, some of these you know, things I think are done by, you know, individuals that might not even work for those particular companies, right? So, but we need to do a better job at that. I agree. But there has to be a forum, which is what we want to create with Open Security Summit. But what we're trying to create here is that forum for us to collaborate.
Mm-hmm.
Cool. So I think we're wrapping up, right? Anything else major you guys want to talk? I think this was quite a successful set of sessions.
I agree.
Yep, definitely.
Thoroughly enjoyed it.
Yeah, me too. Some of my favorites so far at the summit.
Yeah, it's been brilliant.
I think a lot of what Curtis has been saying is actually on the Slack channel as well. He's
Yeah, I
posted a lot of
did
his
put it
thoughts
there.
on there. Yeah, sorry, correct. On the ISG Inspection and Sanitization channel, there's guidance.
I actually put together a little thing of with the images I was talking about and stuff, but I couldn't really send it over yet. It's kind of, yeah, complicated right now.
But actually, one of the things that is also interesting is that if you look at Wallaby, it's a good example of the kind of security research that we should be embracing, right? We should make his life easier. We should give him tools. We can, you know, we should share stuff with him because he can explore this, right? And you know, he might have you know, might do a lot of stuff now, or he might be even more involved in this kind of field, right? So, you know, we need to make our stuff easier, and that's why I talk about the engineering website, Glasswall. That's where the data should come from, right?
Yeah.
Cool. All right.
Would be awesome.
I think we good. All right, Alana, I think you can stop the recording.
Hello?
Yeah, I think you can stop the recording.
Sure. Okay. All right.